Second example is again illustrating the difference between Java and Python. And of course, in any computer, there is just the raw bytes of memory that the processor is then manipulating with the very low-level operations. So all these high-level languages, the compiler does all the hard work of taking our high-level ideas and turning into all that little nitty-gritty of individual low-level operations that is equivalent to our high-level description, so that we don't have to think of the individual details of representation. Now Python does a pretty good job of hiding this underlying reality, the words and all, but in Java we are a bit closer for historical reasons. So as demonstrated in our next example, the data demo. Now the reason that I like BlueJ is the interactive, playful nature. So just right click on a class, so all the public functions are there shown in the menu, and then in the coming weeks when we create objects, we do object-oriented programming, all the objects are gonna be showing in this area, and then we can play around with them at the same time and interactively inspect them and try out their methods. So the data demo, this doesn't do anything useful, but just showcases a whole bunch of things about how to deal with different types of data in Java. So let's look at this primitive types demo first, because it's the important thing about Java and Python. So Java, for efficiency reasons, so this makes a bit of inconsistent, but the alternative would be horrendously wasteful. That in the type system, so there is a distinction between the primitive types. So there is 8 of them, exactly 8, as demonstrated here. They are not classes, most emphatically. So then we see that all these names start with the lowercase. Well, many of these, they have a corresponding class. That one's gonna be in uppercase, of course it's a class. But these primitive types, these correspond directly to the data types that your computer's processor can operate with directly. So the Java compiler, when dealing with these primitive types, all the expressions can turn directly into the Java bytecode operations that probably then just-in-time compiler turns into the actual native machine code of your system. But the thing about these primitive types, like there is exactly 8 of them, and there is for the integers there is 4 different types. So this is now very strange, somebody coming from Python. There's just the one type of integers, but what is the difference? The difference between this byte, short, int, and long. We don't have a byte and short, actually, I realize. So we have a 6 out of 8 in here. So byte is a 1 byte integer. Has a pretty small maximum value, 127. Short is a 2 byte integer. Int, the most commonly used 4 bytes, has a range up to roughly 2 billion and change. So basically numbers that occur in everyday life. Long, so that one's the 8 byte number. So unless you're doing some really special, so your integers are always gonna fit into a long. But then now intentionally demonstrated here. So because each of these integer types has a known fixed number of bytes to store it, and it is now similar to the way that the NumPy works in a NumPy. So if you have an array of 32-bit integers, so 4 bytes, so then arithmetic, if it overflows, so the result is so big that it doesn't fit into the 4 bytes. So this is the Procrustean bed in here. So whatever spills out of the 4 bytes is just ruthlessly chopped away, and the result contains the lowest 4 bytes. So the result essentially is nonsense. And what makes this even more annoying, this overflow, when it happens, so you don't get any indication here in the high-level language level that an overflow has even taken place. So this result, if you print the value of a, so if we run the primitive types demo, so here we can, there you go. So a equals this is very different from what it was supposed to be, so 100 million, so 100 trillion, but this doesn't look like 100 trillion to me. Now long, so can easily handle 100 trillion there. But so here it's just printed, but still, notice how silly the compiler is. If you don't tell it that the number is long by tagging a capital L to the end, this wouldn't compile. So if I take this out and try to compile, notice the error here, errors found in class, so telling that this integer number too large. So putting the L in there, now it's so long. Underscores can be used for grouping. I think this was one of the minor improvements in Java 7 or there about 6 or 7. So then the compiler simply skips these underscores as if they weren't even there. Now for the decimal numbers, there is two types, a float and a double. Usually we use a double. What is this float? So because the way that the decimal numbers are stored and represented with the zeros and ones, there's nothing but the zeros and ones inside the computer. So floating point encoding, so this one is a 4-byte floating point number. Now with the floating points, so it's opposite to ints and long. So decimal number without any qualifier is an 8-byte floating point, so double. And if you want the 4-byte, we rarely do, but if you do, so lowercase f in the end. In the primitive types, char is a Unicode character, so Python makes a distinction between a character and a string. So then single quotes, they stand for a character. Notice the escape sequences are still in full effect. We get a special character, which is this whatever that character is. I just put some random number in there. And the truth value type, important, but notice in Java, true and false, they are keywords, they're not classes, therefore they're not capitalized. So the values true and false, same as in Python, but lowercase. Now for convenience, so that we don't need to be constantly converting between these different types. So the rule is that you can always assign from a more narrow type to a wider one, because it's able to handle. Definitely the wider type can handle what the narrow type can handle. So you can assign from an int to a long, it's perfectly fine. Other way around, so we do a Procrustean job again. So I put the number into the smaller bed. So now if we don't have a cast, so let's take this out and see what happens if we try to compile. Compiler says impossible lossy conversion, because an 8-byte integer doesn't fit into a 4-byte integer. So in this kind of situation, so this concept of casting in Java, you take an expression that has a formal type, the compiler knows the types of all the variables and can those then bottom up infer the type of any arbitrary complicated expression. But the casting, so this one is your prefix an expression with the type in parentheses within reason, and to say the compiler, alright compiler, I know that this expression is not really an int, but let's for a moment together pretend that it is, and I take the responsibility for the things that go wrong. Then the floating point, so a double is big enough to represent any possible int value and then some. So this is quite handy that like if you have a method that takes a double parameter, you can give it an int, and so this so from an int to a double is perfectly fine. I don't think that from a long to a double shouldn't be fine, because the range cannot fit. And the Java strings, so Java doesn't, at least in Java 8, my Java knowledge ends at Java 8, so there what is Java 14 is the latest. Although they come out much faster now than they used to. So I don't know if the current Java has F strings, those would be nice, but the Java way, so it's just to concatenate the string by concatenating the pieces, and this works better in Java than it does in Python. In Python, if you wanted to concatenate to a string, so you had to make sure that the other thing was also a string, so give it to the str function to make it a string. But this Java string concatenation is nice and flexible, so a string can be concatenated with anything at all. So this type can be anything. So this is whatever. This is a double result. So then for the primitive types, of course, the compiler knows how to convert them to the string representation. And then for the classes, the idea same as in Python, you write the magic method. So Python, it's the magic method str, and then in Java, so it's not a magic method, but it's a different method that is guaranteed to exist in every class, no matter what, for the reason we'll see in a couple of weeks. So then you just define that method to return your desired string representation. So that's the primitive types, how they work in Java. So this bit of a blemish in a type system, this kind of a distinction. But if everything were an object and it was still the mid-90s, so then it would be even less efficient than it was at the time.